dark in the pale moonlight.
Good morning, good afternoon, good evening, whatever the case may be. We are back and better than ever. No, I do not have my red dress on, not now anyway. And my summertime sadness, to be perfectly honest with you, is I do not get to meet with you fine people and do some mathematics. Loving the calculus, know that you love the calculus. We are talking today about second and higher derivatives. So we have learned extensively a lot of rules about taking the first derivative. Well, what's this second and higher derivatives? And what's a higher derivative? Well, a derivative higher than a second derivative would be a third derivative, or fourth derivative, or fifth derivative, and so on. Generally in this course, we will just be working with, at most, second derivatives, maybe third derivatives. So, very, very simple. The second derivative of f of x is the derivative of the first derivative. Okay, what does that mean? Well, if you're asked to find the second derivative, you take the derivative, and then you take the derivative again. Very, very simple. And this is the symbolism. We say f double prime of x, or y double prime, or d2y dx2, dx squared, some people say. But this all represents the second derivative. So let's give it a whirl. Okay. Find f double prime of x, given that f of x is equal to x cubed minus 3 of x. Well, I don't know about you, but I'm not going to use the quotient rule unless I absolutely have to. So I'm going to rewrite my function so I don't have to as 3x to the negative 1. So the first derivative of x, hopefully this is very simple to you, would be 3x squared plus 3x to the negative 2. So that's the first derivative. So to take the second derivative, I take the derivative of the first derivative. That's all. No big whoop. So this would be 6x minus 6x to the negative 3. Done. If all you're asked to take the derivative, if that's all you're asked to do, you leave it like that. Maybe if you need to evaluate, you clean up that negative exponent and rewrite that as minus 6 over x cubed. Done. We have taken the second derivative. And if we have to take a higher order derivative, it just depends on the number that is there or the number of dashes. So this could be 28 or 5 or 3, and that would stand for the 28th derivative or 5th derivative or 3rd derivative. Okay, so here we go with an example. Given f of x equals cosine of 2x, show that the third derivative of pi over 8 is equal to 4 root 2. Yippee-ki-yay, we get to do some substitution. Now, I would probably normally write this as with 3 prime marks, because that's just me, Mr. Vegas. I'm just a crazy man. Instead of the 3, but you'll see it different ways, no big deal. So, f prime of x is going to be equal to, so we have a chain rule. The outside function is cosine, and the derivative of cosine is negative sine of 2x multiplied by the derivative of the inside, so that's times the derivative of the inside here is 2x, so times 2, yes. So if we clean that up, which you really need to do when you're taking multiple derivatives, that's going to be negative 2 sine of 2x. Okay, so what's the second derivative? Okay, well, let me change colors. What's the second derivative? Okay, so to find the second derivative, I take the derivative of the first derivative. Again, we have the chain rule. The outside function is sine, and the derivative of sine is cosine. So the coefficient comes along for the ride. So that's going to be negative 2. Again, derivative of sine is cosine, so negative 2 cosine of 2x times the derivative of the inside here. So again, derivative of 2x is times 2. We clean that up, and that becomes negative 4 cosine of 2x. Okay, back to the pink to take the third derivative. And the third derivative is simply the derivative of the second derivative right here. I mean, this is no different. If I just said f of x equals negative 4 cosine of 2x and said find the derivative, then it's just another function that we're taking the derivative of. It just happens to be the second derivative of cosine of 2x. So let's finish her up here. So again, we have a chain rule. The outside function is cosine, and the derivative of cosine is negative sine. So we would have, let's see, negative 4 times derivative of cosine is negative sine of 2x. Okay. Then we multiply that by the derivative of the inside, which again is going to be 2. And we clean that up, and we have negative times a negative is positive. I have the 2 outside, so that is going to be 8 multiplied by the sine of 2x. Okay? And we have to show that f triple prime of pi over 8 is equal to 4 root 2. So f triple prime of pi over 8 is going to be equal to, and all I do is I replace x with pi over 8 in my third derivative here. So that's going to be 8 times the sine of 2 times pi over 8, which equals 8 sine. 2 times pi over 8 is 2 pi over 8, which is pi over 4. And I know you know instantaneously that the sine of pi over 4 is root 2 over 2. So that's going to be 8 root 2 over 2, which is equal to 4 root 2. And we have shown what they wanted, as requested. Okay, that's all I've got for now. Hope you enjoyed it. We will see you next time with no summertime sadness. See ya!